Morning. All right. Next one is from Patty. Yeah, we've had Patty questions on here before. Good morning. Yeah. Hi, Dr. Ben. How you doing? I just read the news regarding the breathalyzer test. Yes. And I didn't know about this until I just clicked your link, which I only did a moment ago. But yeah, okay. So this is talking about a test that's coming out of Israel, which they're calling like a breathalyzer for coronavirus, where you breathe into a little, it looks like a little kazoo, basically. And inside the little kazoo, there is a chip, and the chip is going to capture virus particles that come out of your mouth, and then it's going to try to detect them. And they're being a little hedgy on exactly what's going on in there. And so it's hard to tell. There are a couple ways they could have made this chip. So if they have a chip and it's covered in antibodies well, let's back up a step. So they're trying to use physics to detect viruses. Physics can detect a virus, but all viruses kind of look the same to most physics tests that you can easily do. Even taking an electron microscope picture of a coronavirus just tells you that it's probably a coronavirus or one of the related viruses, and will not at all tell you which coronavirus you're dealing with. Yeah, there are just not enough differences between really different coronaviruses. They all kind of do look the same. Yeah, so there we go. All right, my coronavirus racism, yeah, out of the way. Yeah, now let's go to the way they can detect them. So you can't do it with just physics, but if you combine biology with physics, then yes, it becomes very possible. The biology element would be something like an antibody. And so these are little recognizer molecules, and their job is to be specific. Their job is to pick out one thing from among all the things that could exist in the world and stick to it forever. Yeah. And they don't all do that job particularly well, and none of them do stick forever, but they try. That's the important thing. And so if you build in something like an antibody into the test, if they had like a little layer covered in coronavirus catching antibodies, then you could breathe in and your virus will get caught on one of those. And then they're saying they're detecting it with, what was it? Something like terahertz frequency resonance, which could be a couple of things. But yeah, they're doing something which is wobbling atoms or bonds inside the molecule. And there are a couple different ways to do this. NMR spectroscopy is one, Raman spectroscopy is another. Yeah, I'm not sure from the press release exactly what's going on there, but it'll be something like that probably, or an analogous technique. And then, yeah, you can detect that a virus is caught with the resonance, and you can detect that it's probably going to be the right coronavirus because you have the coronavirus catching protein on the bottom. And those antibodies are very specific. So if they built it that way, then yeah, it would probably be able to pick up coronavirus if you are breathing coronavirus out, which is kind of the point. If you're breathing coronavirus out, you're you're a danger to society at the moment, just for like 2 weeks, yeah. And yeah, you're probably about to be pretty sick. So this is a useful thing to know. If it is just a sensor that is detecting, which is kind of what the article is suggesting, if it's just a sensor that is detecting things that physically resonate like a coronavirus, then no, it wouldn't be able to tell mouse coronavirus from human coronavirus from one of the other 6 human coronaviruses that's not SARS coronavirus 2. And all those other things are pretty common in the world. And as are other viruses, it may not be able to tell an influenza virus from a coronavirus. It's hard to say. So until we see the paper where they go through and do all these tests and show exactly, what they're put their little machine through the paces, we're not going to know exactly what it does. It's a neat concept, and I like that it could be fast. I'm not sure if the detection part after takes a lot of time or fancy equipment. I'm guessing there's some level of equipment involved. But yeah, it could be good. Yeah. But yeah, until we see the paper and they show all the details, then I'm not going to get all the way on the bandwagon. I'll have one little toe up on the bandwagon, getting ready. Yeah. So thanks very much. Interesting paper. Glad you brought it to my attention. This is Ask Dr.